welcome back. It's been a while. So, what has happened? The G-EDM project. I still don't have a working pulse generator because I underestimated how essential the DPH9809 would be in the project. I thought I could just use an existing constant current power supply, but it's very much an integral part of the pulse current limitation. Its electrical characteristics, its inductance, capacitance, and regulation speed are just very much tuned to the G-EDM power supply. So I'm waiting for that to arrive. It's supposed to be here in like 2 weeks, but it could take a lot longer. It comes from China. I have started writing some documentation for the project. Like, information is just scattered everywhere. I just created a little documentation site. So far it still doesn't have that much. It has some sourcing guide on where to get the boards, where to get power supplies, EDM wire, flashing firmware, compiling firmware, bug fix guides, community stuff. It's very small. Half the pages are still placeholders, but it's a good start, and I'm hoping I can expand on that some more, and maybe some other people also expand on it some more. It's just Markdown to documentation converter, so you just write your documentation in Markdown, and the GitHub action compiles it into a GitHub page and hosts it for you. If this gets officially accepted, we could also move it to the G-EDM repository, but for now it's just hosted on my GitHub. We'll see where it goes and if it comes in useful. Then for the G-EDM, there's also been some development about boards and selling them. Like, the main creator sometimes sells boards, but he doesn't really want to do that regularly, and so far it's mostly just you either order it from PCBWay assembly services or you just assemble it yourself, which is kind of rough for new users. In the Discord, we've created a market channel where I am going to offer some boards, both just the PCBs and assembled. I have extra boards of the Evo 2 and 3 motion board, as well as Evo 3 and 4 pulse board, as well as most of the components. So if you want one G-EDM first, he still has one board he's gonna build, but after that he's probably not gonna be in the manufacturing part of the project, mostly just going back to firmware from what I've gathered. So yeah, this is pretty good, makes it easier for newcomers, both this and the documentation. Then what else do we have? I've spent a lot of the past weeks trying to get into power electronics, especially switching converters, since that's very much required for building an EDM power supply. Like with the G-EDM, we are just kind of outsourcing that by using the existing DPH supply for doing the current regulation, but that's obviously not really meant for that, and I'll have to investigate like pulse current shapes and stuff like that once I have it set up. So having a custom switching power supply for an EDM supply would be really cool, but it's also a difficult problem. With EDM, you're getting into the higher power section. Ideally, you'd have like 100 volt open voltage and 30 amps up to pulse current, so you're talking about 3 kilowatt potential output range. You'll probably have 30 volts coming out of the output at those 30 amps, so that's still a 900 watt pulse, so we're talking about pretty beefy power electronics that also need to switch at pretty high speed just to respond to this rapid changes in loading. Like, my first idea was to build a constant current driver and feed it the square wave, but at 1 microsecond on times, that would be 500 kilohertz of frequency, and your regulation loop would have to be above that. So you would be looking at like at least a switching converter running at 500 kilohertz, if not megahertz, which is like out of the range of normal switching converters. Even 500 kilohertz is on the upper end, and that's usually for like lower power converters. With larger MOSFETs, you have all these issues with larger gate charges, worse figures of merit, just a lot of problems. And you could go into more exotic materials like germanium nitride transistors, but starting out with power electronics, just having built my first few buck converters from scratch, I don't feel comfortable building kilowatt scale GAN converters. I did see the OpenEDM project, and they have a very interesting switching converter. I don't think they say that officially, but specs wise it seems like they've oriented themselves on the Bax EDM machine with 30 amp pulses, very good current control. I think they're claiming 5 microsecond pulses, but they are not saying that's the limit. That's just what they've done experimentally, so I'm sure that can probably be pushed down to like 2 microsecond or 1 microsecond pulses pulses, and at that point you have all the control you could want. I want to go over their stuff in more detail, but here's like the basic idea. You have a large inductor and you first charge the inductor, then you let it coast when it's at the wanted current, and then in the arc stage you discharge it through the spark gap. And this is a topology I've thought about, but the part I was missing was this diode here, because the spark gap takes some time to break down, about half a microsecond to 5 microseconds. If you just have this inductor with like 20 amps running through it and then you suddenly remove this path, you just get a huge voltage spike. Without the diode, this design would just trade off having bad current control for having bad voltage control, and you would not get a consistent spark distance. But what they're doing here is they're using a diode to actually backfeed the inductor current into the voltage rail, and in a later revision into a capacitor to keep it stable. If the inductor pushes a higher voltage than the voltage rail, this diode will conduct, but as soon as the spark gap starts conducting, it'll no longer be higher, and so this diode will turn off quickly, which is quite smart. I think this design has a lot of promise. I'm trying to understand the version 2, since that's a lot more complex. They've introduced the different capacitor banks, and just dumping a bunch of current into your voltage rail is usually not the best. It'll just make it also move up unless you have huge capacitances on that, and most power supplies don't really like sinking current. This is a really cool design, and you have a state machine that runs through these states. They have state transition diagrams as well. It's kind of a bit under-documented. The GitHub repositories themselves don't have too much stuff in it. I think I'll just have to read all the messages posted on their Discord for the last month to get more information. So this is not really ready to be replicated, but it's very promising. Once this works well, it'll probably be one of the most competent EDM power supplies in the open source scene. So this is really cool. I highly recommend that. They have like a few cutting demos on their YouTube, but they're very sparse on information otherwise. Did build a few buck converters. Got one to run a constant current arc through a spark gap, which was kind of magical. You know from using a TIG welder that it is quite possible to have an arc with just a few amps of current running through it, but it still feels odd to know like, oh yeah, this arc, it's just 3 amps of current. It's not some crazy amount like you would normally expect going through there, and regulating that is a bit of a challenge. I do want to go in depth on how actually the spark gap works, since it's quite interesting. I didn't understand it for quite a while. I hope to be releasing a video on that soon. But yeah, I finally, probably years late, discovered how cool the Raspberry Pi 2040 and the Raspberry Pi Pico is. I've always kind of dismissed it since I focused so much on the MicroPython aspects of it, and that just felt like, oh cool, you have a more powerful CPU so you can use higher level languages. But the PIO stuff, the programmable input-output peripheral, is super cool. It basically is 8 very small cores that have a very limited instruction set, but can talk to outputs very well, and you just configure those to bit bang out your protocol. And these seem perfect for any kind of high speed. They can clock at up to 133 megahertz and do read and writes every cycle. I don't know what the actual bandwidth of the output pin is, but that's crazy high throughput, and from there you could go into like a DMA buffer. They're quite limited what they can do compute-wise, but just shuffling data around or implementing a basic state machine should be more than fine. I've even seen a project where they implemented an oscilloscope with external ADCs, and I'm pretty sure they ran that through PIO and got 50 mega samples a second. That would be really cool for a pulse generator. You could have like a full oscilloscope on there viewing the actual pulses with 50 mega samples or even 5 mega samples. You would get many data points over each pulse. So I want to play more with those. Really cool. I've also got new fluxists and even solder paste, so I can more easily assemble boards. Now I've had problems with cheap solder solder paste just leaving nasty residue and not really letting tin-based solders flow. So I hope this V5TF works. I think they're called Steri, if I remember correctly. They are like very similar to the good Amtech flux that's been discontinued. So I hope I get some really good flux out of that. I got a big tube, we'll see. And also like the solder paste, I've got a T4 solder paste, so moderately fine balls coalesce pretty easily. I don't have any solder stencils, but I can make them, I'm pretty sure. I just have to develop a process for the fiber laser to cut stencils. Or else I'll probably just order one the next time I order a board. Do some hot plate reflow probably. That's gonna be pretty cool. I also got some high quality solder from them and hopefully gonna have less problems with cleaning up flux residue, better solder joint quality. So yeah, that's pretty much it for now. Check the Discord if you want to get started with G-EDM. If you want to contribute to the docs, I highly encourage that. Okay, so see you again soon.